Hello and welcome back to my repair shop. Today on Classic Arcade Repairs, I'm going to be looking at two Kangaroo board sets. They're from Sun Electronics and they're identical sets. And preliminarily, I have done some testing on these two sets. And what I have found is both of the video boards are fine, which is a good place to start. One set, the CPU board works minus sound, so it's obviously got a bad sound amp or something like that. The second board, it seems like the sound amp works okay, but the CPU board itself is completely dead. Comes up with just garbage and nonsense. So we'll go through both of those. We'll do the no sound one first because that'll be easier. That'll be maintenance with doing caps, replacing the capacitors. It's probably going to need a new sound amp, so we'll do that. And then we'll move on to the more difficult one. So this is going to be a 2-in-1 Kangaroo Sun Electronics. So let's go ahead and get right to it. Alright, and this is the first board up for repair. This is the one that actually does work. Comes up fine. Yet there is no sound. And what is this? What is this stuff? You know what? I need to look at the schematic on this board set. I think actually this is the sound section. This is the sound processor. And I know that the sound actually works because if you turn it up, I got the furnace on right now, but if you turn it up as loud as it'll go and you play a game, you can faintly hear something. You can't hear it with the furnace on though, but you can faintly hear something out of the speaker. So I know the sound is there. It's just not being amplified. So this is going to be an amp. We'll replace the caps. We'll replace all of the electrolytics on the set. And we'll go through and I'll inspect all of these sockets and make sure all the sockets are looking good. I'm not going to replace them if they look good, but we are going to replace capacitors because not all companies used good capacitors back in the day. And these things do leak and do corrode boards. So we're going to go ahead and replace all of the capacitors. And I'm thinking, after I've seen some in some of my repairs, let's start here. I didn't always replace electrolytic capacitors, but I think I'm going to start making it general practice to replace every electrolytic capacitor on a board because I've seen too many of them either open or leaking. I'd say 95% of capacitors are probably good. I don't know, it's a tough call. I guess it's going to be the brand of capacitor that's on the board and how it looks. If it's a Nichicon that is not leaky or no signs of leakage, I guess I can leave it because those are good caps. But anything that's like an off-brand, like these are getting replaced. I guess it's axial caps. Axial caps are easy to see if they're either leaking or what brand they are. These ones you can't really see. So I guess any cap that is radial like this from here on out will be replaced. And then the axial caps will be kind of a discretionary thing. Number one, are they leaking? Do they show signs of leaking? Number two, what kind of cap is it? If it's a Nichicon cap and it looks fine, I'm not replacing them. But if it's some off-brand, some brand that I've never heard of or something like that, maybe I will replace them. I guess that's going to be the new standard. All radials get replaced, period. Because you just can't see underneath them. And in these sections, they're just driven so hard. They're not signal cap. Well, a lot of them are, but a lot of the power caps up and like in a sound section just get so bad. So yeah, I think that's going to be the new norm. I'm going to replace all the radials. but not necessarily all of the axials. All right, so let's go ahead, turn this off, take this board set apart. I'm going to desolder this amp, put a new amp up in it. I might even put a heat sink on it if I have something. We'll see what I got. And yeah, then get this thing recapped up in here, do a little inspecting, and then call it good. This one will be done. Then we'll move on to the more difficult one. I could just do all of the recapping all at once on both board sets. So I'll do that. I'll recap both board sets all at the same time. So let's get set up and do that. All right, putting set 1 back together. I got the 3 rail filter caps replaced. I have a new amp in. And this original amp is a MB3713, and it's the same amp as a 3712, which is what I have in stock. It's just the pinout is flipped. So you have to put your MB3712 in backwards. And which is kind of cool because I can place a IC heatsink on that, and that'll look good. I've replaced all these caps, replaced this little cap. Put this together. Boy, at least I'm hoping that's the case with that. I'm pretty sure that that is the case with this amp, that it's just a flipped polarity. And if it isn't, then it just won't work. And it might blow up, which would be fun. So we'll see. I haven't blown anything up in a while. That'd be kind of fun. Put that guy on. My little makeshift JAMA adapter here that I put together. Okay, we're hooked up. I got to get it plugged in. Hopefully we hear the speaker pop. Okay, here we go. I hear sound. Waiting for the monitor. Okay, there it is. It's up. Very good, very good. Let's mess with this pot. Well, that pot needs to be cleaned. It feels like crap. Spray some deoxit in there and work it. God, that feels rough. That's a rough pot. Let's set it kind of right about there. And let's coin this baby up. Coin is solder side 2. Okay. All right. Here's my inputs. That's down, jump, left, All right, let's. Let's punch. That's all the controls. Okay, I'm going to grab these IC heat sinks. This has adhesive on the back. I'm going to turn this off. I'm going to turn it off. Okay, and what I'm going to do is I'm going to adhesively stick this to that sound amp. First thing I'm going to do is I'm going to put some alcohol on a Q-tip, and I'm going to clean the bottom of this amp. All right, and dry it. And we'll get a good stick on this. These things stick really good. Really good little heat sinks. And just press it right onto that. Hold it for a minute. With some pressure. That's going to be good. That's going to have that. I'll bring you down to check that out. Yeah. Check that out. Nice little heat sink. This is the original amp right here. Like I say, it's a it's an MB3713. It's the same as the 37112 that I stock. It's just pin 1 on this one is marked on the back of the thing. Right here, a little notch. So pin 1 is over here. Well, on the 3712, pin 1 is over here. It's just reversed. So you have to put it in backwards. Just like that. Cool. Alright, this guy's done. So now we can move on to board set number 2. Let me get that up on here. And we'll start with that one. That one's going to be a little more involved because it's actually dead. So let's get it up here. First thing I got to do is I got to do the caps. So I'm going to go off camera. I'll do all the caps on the other board, and then put it together, and we'll look at it together. Okay, we got this guy all capped up. Nice brand new Nichicon caps, so it's good for the long haul. Cap here. And this was a 104 that was busted, so I replaced that. And I got these 3 rail caps. So we're good to go. So we'll go ahead and put this all back together and work on this board. We already know this board's good. It's this board that has the issue. Way before I even started any of this, I did swaparooskies between boards and verified that both of the video boards were okay. So this one's got an issue, so we'll work on this guy. Okay, now we got this guy all hooked up. We have to plug it in. Let's unplug that. Plug in our power supply and our monitor. Okay. And you'll see what this thing does. It doesn't do much. It's on. You can definitely hear the speaker. We know the amp's good on this one. Yeah. This is what we get. That is just a total failure to run. We could start with the obvious, and we can put a new Z80 in it. And I don't know what kind of handshaking this does between the sound circuitry. I don't know what this is. Could this be making it not work? I don't know. Do we have some kind of a ROM decoding issue? Could be. First things first, the easiest thing is let's put a couple good CPUs in it. We know the CPUs on the other board are good, so let's put those two CPUs in this guy. Let's replace these 3 chips from the other board and see if we get anything. Because this might be trying to communicate with the soundboard and get some kind of handshaking going, and it's not working. So it's hanging up. This could just be dead. Who knows? Maybe it can't read the ROM. We'll find out. Okay, I've pulled those 3 chips out of the other board set, and they're right here. And the good news is these sockets are nice dual wipe amp sockets. Yeah, those are fine. We'll put this Z80 in here. And yes, these are the good Z80s out of the other board set. And our AY-3-8910 sound generator. Okay. Notches are all correct. So let's go ahead and see if it does anything different. Watching the screen. And it's the same thing, same garbage. Yeah. So it's not the chips. Yeah. Same exact garbage. So it is a logic failure, which is fun. Hey, we get to find a logic failure on this thing. So I'm going to pull the little scope out and get it up on the bench. We'll use that guy today. Be right back. And since this is right available to us, this is the good board set. I took these 3 chips that we pulled out of the other board and popped them into this board, and we're going to see if those chips are good. Little swapperooski. Make things easy on us. Especially, we got 2 board sets here. All right, I'm going to give you a bird's eye view of the oscilloscope, what I affectionately refer to as the little scope. And I'm just going to poke around. I'm not even looking at a schematic or nothing. I'm just going to poke around at some. It's a Z80. I know all the pins on a Z80 pretty much. And I know the buffer drivers. Ooh, there's 221. Ooh, this could be our whole problem. I didn't see these. There are 2 2114 RAM on here. I guarantee you that's our problem. You know what we can do? I'm going to turn this thing on. and I'm going to bring you over here. You know what? I'll cut away really quick. I bet you if I jump those two rams, it'll come to life. So hold on one second. All right, what I have gone and just decided to do, there's about a 95% chance that it's program RAM. There's two 2114s right here. And those are going to be the CPU's program RAM. And my guess is one of those is bad. What I'm going to do is I'm going to remove both of them and I'll test them in the Inquisitor. Put sockets in there, and if they're both good, we'll put them back in the board. But I believe that that's going to be one of the issues, or the issue. And if not, then we'll move on to the logic. I just want to eliminate this first because this is more probable than a logic failure. And just probing these with an oscilloscope or a logic probe is not going to tell you that they're bad. Sometimes you get lucky and something's just pegged low or something like that, but for the most part, it can be internally bad to where it's just not choosing the right memory cell, and it's spitting out garbage data that's just not right. So we'll have to put it in the Inquisitor to properly test them. So I'm going to go ahead, desolder these, test them, put sockets in the board. And if one of these is bad, then we know we found our problem. So, all right, I'll be back. All right, I tested both of these 2114 RAM chips in my Inquisitor, and they are good. So this problem is not those RAMs. I even put new RAMs in there just to be sure. It's not the RAM. So there is a logic failure on here that we will be able to look at in the scope. So, yep. I just wanted to eliminate that really quick as an issue. That's not the problem, so we'll go ahead and start probing around. Like I said, I'm not even bothering with a schematic. I'm just going to start poking around on the board. Up in this section, this half of the board. And maybe some of this stuff too, but mostly up here. I think is where we're going to find our problem, but we'll see. All right, we'll get set up. Okay, let's try this again. Go ahead and turn the game on. And let's do some probing. Pin 26 of the Z80 is reset. Not resetting. Okay, Z80 pin 6 is the clock. Good clock. And that's about all I know of the Z80. I forget it. I'm going to have to get my sheet out. But let's just probe these RAMs. Here's pin 10 is the read write, I believe, and chip enable is pin 8. So they're both being enabled and chip and the signal is good. That looks good. Okay. Alright, let's just do some probing. This is a 367 which is enabled all the time, so this should look just like that. And it kind of does. Same here. Right? And this one is also always enabled. Good. 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 Good, good. These might be address buffers or something, I'm not sure. Always enabled. There's another 367, by the way. Okay. No, those look good.
And let's see, what else do we got? Here's another 367. Enable is low. That looks good. Good. Okay. All right. Alright, those 367s look to be okay. Now this chip looks like crap. I don't feel any heat. Some of these chips look terrible. Yeah, here's more RAM, more 2114. I believe that's program RAM for the sound. I don't think that would be an issue. It could. If the sound won't initialize, it could be an issue. I don't know. Here we have a, what is this? It's so rusted out I can't even tell what it is. It's a signal and a signal. It's probably a gate like a 00 or something. High. High. Is it an AND gate? No. If it is, it's no good. A high, 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 high. No idea what that is. Let's look at the selects for the EPROMs. 13, 14, 15, 16, 17, 18 is high, 19, 20 is signal. Alright. 18 is high. 18 is high. 18 is not high. 18, 19, 20. Okay, that one's being selected. That one is not. That one is not. That one is not. So it's all up to this one. One EPROM is being selected. Dun, 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 dun. Dun, 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 dun. Low, high, low. So 0, 1, 0, 1, 1, 1, 1, 1, 1. 13, 14, 15, 16, 17, 18. This one is not being selected. 18. It was. What's going on here? This one was being selected. No, it's not. Now there's no addressing going on. Well, yeah, there is. Not like there was. I think the EPROM might be bad. I mean, it's possible. These are fine. They look like crap, but they're fine. This board needs to be washed. Yeah, this board seriously needs a washing. It's your 2732, and they're not doing anything. Now the RAM is not being written to now. This thing is totally just stopped doing whatever it was doing. It stopped. I want to know what this chip is right here. This guy right there. This board's got some rust issues and dirt nastiness issues. So I think I will get the other board, reference what this is, and try to probe it. Let me do that really quick. Okay, just probing around in this area, I found the problem, or I found a major problem. This guy right here is a 138, and those are used in decoding, and that might be the ROM decoder, I'm not sure. It's a 138. We can look at our input, select inputs, pins 1, 2, 3. Those are our select address bits. And then our enables, there's 3 enables. These are the low enables. Okay, that is a low enable, and this is a high enable. So those are our enables, and these are our output bits. There's bit 0. Bit 1. 2, 3, 4, 5, 6, and output bit 7. All 8 output bits are dead on that 138. This is a 42, which actually when probed looks to work, but that thing needs to be replaced. That needs to be replaced. This needs to be replaced. This needs to any of these junk rusty, this junked out rusty junk is getting replaced. So let's do that. Let's replace, a handful of parts here. Clean this board up. I'm going to wash this board and go from there. Yeah. Be back. All right. Well, I gave this board a good cleaning, and I think it came pretty good and clean. A lot of the chips I just scrubbed, and a lot of them came pretty clean. They're not great, but they're not god-awful either. I did remove that 42, and it tested good. So what I'm going to do, and this is the 42 right here, and you can see it's got some rust on it, and it doesn't look great. But the legs are okay, and I got to replace that. Yeah, that looks like crap. It's a shame too, because it does work, but it's just too rusted out. So I'm going to go ahead and replace that. This one actually is bad, as I thought, as I showed you on the scope. It's just no good. It tested bad in the tester. So let's go ahead and socket these two, put 2 new chips in, and then hook it all back up. Okay, we're all hooked back up. New chips in the board. All polarities are correct. Orientations are correct. 7, 5, 6, 7, 8. All right. Well, by golly, let's fire it up. See what we get. Is it going to work? No, it's not. There are more problems. Okay. All right, be right back. All right, I hooked the big scope up to it, and I'm just poking around, and I came to this. This is a 367, correct? Yes, 367. Pin 1 is an enable, and if I probe pin 1, we have a floating signal on an enable. So that is definitely not good. So we got to find out where that signal is coming from. This enable signal. This is at 138 that I replaced, and now you see the outputs are all nice. There's a 0, 1, 2, 3, 4, 5, 6. That one is a signal, and 7. So that's not 7. That was shorted. That's 7. So that definitely looks good now. So we just need to find out what is enabling that guy. And this is kind of a nice exercise of going through here and doing this without a schematic. Just kind of probing around. It's not really a complex board. There's not much to it. So you can just probe around on it and find your bad parts. All right, I'm going to track that down, see where that goes, and then we'll check that out. Okay, I've gone ahead and traced pin 1 back to pin 4 of this 155. And if we look at 155 here in the big data book, a 155 is a 2 to 4 line decoder. It can be used as a 1 to 4 line demultiplexer, 3 to 8 line decoder, and 1 to 8 line demultiplexer. So it's a pretty versatile chip. You can have 4 functions out of it. And we have 2 sets of input or outputs. This can either be a dual chip or a single chip. So you can have 4 outputs over here, 4 outputs over here, or 8 outputs altogether. So if we just, I traced that back to pin 4 on this output side. And if we just look at pin 4 of this guy, that's what's floating, all of these outputs. 4, 5, 6, 7, and the other side outputs, all floating. But all the other signals, all the control signals are all there. Yeah. So there's all of our control signals. This thing just has no outputs. This guy right here is DOA. So we'll replace that 155, and maybe that'll do it. So let's go ahead and replace that guy. Okay, new 155 in the board. Socketed. And let's go ahead and fire it up. Nothing. No worky. Okay. Huh. And it's like absolutely nothing. What's going on? Well, back to the old poking around board. We get the scope back on it and do some more poking around. Something ain't right. Okay. I'll be back. Okay, well, out of curiosity, I just put a different 155 in the board, and it comes up
to this. It's actually running, but this CPU board is not communicating with the video board properly. There's something going on there. But the game is actually working. You can see it in the background. And I bet you we can actually play a game. I'll coin it up and do that. And then we'll just have to figure out how the this board just is not talking to the video board right, apparently. Something ain't right there. So, and apparently I'm going to have to take my 155s inside and test them all on my my TI 8662 Plus, because that one that I had in there, it didn't do anything. So it was definitely not good. Let me go ahead and, yeah, let's do it right here. I'll just kind of straighten this out, hook it to ground, and see if we can coin this up. There's no sound, unless it's turned all the way down. Yeah. And that is not an amp issue, I don't believe. I think that's actually a sound issue. So, boy, this board's got issues. So we need to first, before we mess with sound, let's mess with the video part of it. Because it did coin up. It coined up and I started a game. It just didn't have no sound. So, yeah, we'll go ahead and fix the video first, and then the sound. Be right back. Okay, I have been out here probing around and messing around with this board, just kind of eliminating things as issues. And I've went through a lot. You can see a lot of green dots. Those are chips that were actually analyzed on the little scope. Some of these guys down here, and I did, this one was not being enabled at all. These two I don't think, so I didn't bother with those. I believe that this decoder in the sound section is bad, so I'm going to remove that. It didn't look right when I was probing it. I'm going to go ahead and remove that and the two RAMs. I'll just throw the two RAMs in the tester. It'll be good to have sockets there anyway. But I believe I'm kind of down to the thought. I've eliminated ROMs. ROMs are not the issue. I actually did ROM swaps between the two boards. I am to the point where I think that this custom CPU is the problem. And the only reason I think that, really, is because of this circuitry. I'm getting no enable on this line right here, which is input 3, which comes from the 155 right here that I replaced. I know this chip is good. It's not a problem. And that chip gets its inputs from the address, basically, address, and from the CPU. It's a CPU-driven decoding. Now, this thing outputs D0 through D3. It basically manipulates the first 4 data bits. That's really all this thing seems to do. I don't quite exactly understand what this thing's purpose is. I'm not gonna lie and act like I do. It looks like it's just some kind of data manipulation. I don't know exactly what's going on here. But I do know that it influences the first 4 data bits. Some kind of a security thing or something. I'm not exactly sure, to be honest. I just don't know. So I'm going to remove this one and the one on the other board, and I'm going to swap these two chips. So I'm removing both of these, the 42 pin chips on both boards. I'm going to remove the 42, these two RAMs, just because I think this is my sound issue right here, these 3 chips. Well, the RAM I don't know about, but
this guy right here, the 42, which is, if I go to the sound CPU, if I can get there, the sound microprocessor. Yeah. RAM, yeah. Yeah, this decoder enables the RAMs. So, I mean, I guess I could put the fluke on there. I don't know. I'm going to go... Oh, and that's another thing. I put the fluke on this, and the fluke will not work on this. It keeps continuously timing out. So that kind of also tells me that there's something funky with the first 4 data bits going on. Possibly. So anyway, that's my theory. So I'm going to go ahead and remove this guy and do a swapperooski between the boards and see what happens. Okay, I went and replaced the 42, which kind of crumbled as I removed it. One of the RAMs was bad. This one is replaced. This is the CPU from the board that was working, the custom CPU, and this is the board that was working, and I put the custom CPU from this board into this one. You can see I have this one marked with a green dot, meaning it came out of the working board. So this one out of the non-working board is now in the good board, and the good news is it works. That is the good news. It's not the custom CPU, which is nice. And now they're nicely socketed. So we have a different issue on here. I'm gonna check on the cable. I mean, it might have a bad cable. Well, no, because this is the same cable that I had on that board. No, it's not the cable. This cable works with this board, but does not work with this board. So it's not the cable. So yeah, it's the board. Something on the board yet. What? It's not the EEPROMs. It's not the CPU. I don't know. You know what I'm going to do is I'm going to put the fluke on this board, because when I tried putting the fluke on this one, it would just constantly time out. So that'll tell me that it's a CPU signal. If this one works fine, then I know that we have a flaky CPU signal on here, but I don't understand why it would run. I don't know. I'll find out. We'll find out. I'm going to go ahead and just put the fluke on this one, see if it's all works good and all that. And that might be a clue. If this one works good, it could be a clue as to what's going on with that one. So let's go ahead and do that. I'll throw the fluke on this guy. Okay, yeah, this is just something to do with this board set. And it might have something to do with how this custom CPU is dealing with the data bits or whatever, because this is just doing a constantly doing this. I wonder what would happen if I remove this chip. I'm going to go ahead and shut everything down and remove this and try using the fluke. Nope, it's the same thing. No, the fluke just does not like this board. So, all right. Yeah, I can use the fluke on the sound processor, and that works fine. Which do I have? CPU 2, yeah. 0 to FFF on the ROM. And it is a signature of 364E. 364E. It's unfortunate that I can't use it on this processor. I wonder why. It's got to be some kind of some weird CPU thing with this board. I don't know. The fluke just will not like it. Yeah. Well, that seems to work fine. Interesting. Huh. Oh well. That's unfortunate. Okay. Well, I'll continue on poking around a little bit. I might take a break and play some games. I got Millipede over there. I got Space Invaders working. I got my Pac-Man on and my Donkey Kong. So maybe I will play some games while just to kind of unload my mind on this a little bit. All right, I'll be back. Okay, actually you can use the fluke on this. You just can't do a bus test. I was able to do the 2 RAM here, and I'm doing the ROMs right now. You can see it just went okay. But watch if you try to do a bus test. Yeah, you just cannot do a bus test. So stop. Do ROM 2000 to FFF. And that is D8F7. D8F7. And testing. So you can do your RAM and ROM checks. It doesn't let you do a bus test for some reason. Yeah, I don't know. Very weird. And this is the working board, by the way. So I really need to put the other board on here as this one works, but yeah. Okay. All right, well, I'm going to continue. I'm going to do all, see, that's okay. I'm going to do all the ROM and RAM stuff, and then I'm going to put the non-working board back on and do the same thing. Okay, I got the non-working board back on, and I was able to do all of my ROM checks and the RAM check and everything on this board, and it worked fine. And the good news is, after replacing the bad RAM and the 42, which fell apart, was it good? I don't know. It fell apart when I took it out, though. No, it didn't look right when I was probing it. So now we go and coin up and... So our sound is working good, but we still have no color. Yeah. I'm going to turn it off. So sound is good. Done. There's something going on, and I looked when I saw something interesting in the I saw something interesting in the memory map here. It says DMA. Picture data. Color shading latch. What is the color, the shading latch? So I'm going to have to look over this CPU schematic better and find that. That could be something right there. Color latch. I mean, it sounds kind of important, don't it? So let me go ahead and look into that. And there could be a bad latch on here. Color latch, to be exact. So let me investigate a little bit better on here. The good news is our sound is fixed. I know that the CPU has all of the access to the RAM and ROM that it needs. This is just it's a failure communicating with the video board. So there's like DMA stuff. There's this color latch. It's something funky in that circuitry. So we'll just have to find it. Yeah. I went through earlier and just did a lot of the basic simple gating chips and kind of eliminated those. There are a lot of latches on this board. There's 175s all over the place. So, and there's still more of this stuff, but I think this is I think this is sound stuff. I don't know. We'll figure it out. All right. I think what I might do is take a blue paint pen and go over the sound part of the schematic. And just, yeah. Every chip that's in this sound section, I might put a little blue corner on. So I know just to, don't even worry about it. You know, unless it's a gate that might be sharing something. But if it's like a 74, you know, that kind of thing. It looks like 41, that whole chip. 49, that 49, 48. Yeah, I don't know. We'll see. It doesn't look like there's that much really that is involved in sound, to be honest. So that's good. It leaves a lot more for us to look at. All of these 175s look like they deal with communicating with this board. It's probably DMA latches and stuff. So yeah, interesting. Okay, I'll be back. Well, it looks like I found the problem. And you know, I've been kind of dancing around this chip the whole darn time. I don't know why. I think because I probed it and I saw what looks like good signals on it. But I am on it now, or am I? What's going on here? Enable? No, I should be down here. Let me look at this again. Something don't look right. I don't think I'm hooked up right. Okay, actually I just didn't have the most significant output bit hooked up, which is irrelevant really to this. Now it's hooked up correctly. This side over here, the low side of this works fine. The high side is messed up of the 139, which is right here. Yeah. Those three signals right there are goofed up. And they look like they go to the other board. They go to the video board. And since I got put onto that chip, you can see there's some color showing up now. And the game's playing in the background. I did find another bad chip though. It was right here. And all that it did was the coin counter. It's the only thing it's responsible for doing. It's 367 right here. Yeah. It was just those two gates. 14 out to 13 and 12 out to 11. I think those are used. The rest of the chip is used elsewhere on the board. The rest of the gates were fine. It's those two that were connected out here somewhere to the coin outputs. The coin counters were bad, so it didn't have anything to do with the operation of the game. Coin counters wouldn't have worked. But, yeah. So this is going to be the problem. If we look at it, I've got it just triggering on enable. And you can see it's enabled, but it's just kind of doing whatever it wants to do down here. You see that? This is a 139. When it's enabled, whatever's on the select line should go to 0 on here. So 0 should be 0. Well, it is, but yeah, but so is 2. You know, whenever this is disabled, it should be 1s all over. Yeah, this thing's jacked up. In contrast, we can go to the other side, the low side, and you can see here we're triggering on 2, and it's 2 there. We go to the trigger. Let's clear the trigger. And let's trigger on 0 here. And let's kind of, yeah, see? It's enabled, it's selecting 0, so the 0 bit is low. But when it's not enabled, you get 1s. So this side works, the other side is totally messed up. So we need to replace this chip right here. And I believe that'll fix the whole board. So let's go ahead and do that, replace that guy. Okay, and I've replaced this guy with that guy. And this thing does test bad, no good. So let's go ahead, I need to plug in everything. The power supply, monitor, and fire it up. It's on, hopefully our colors are correct. All right, that is what I'm talking about right there. All right, that looks good. Looks like another board set fixed. Excellent. All right, I'll just go ahead and go through the, the controls really quick. And then I got to let both of these guys cook, especially this one. I might let this one run for about 5 hours tomorrow. Because a lot of these Fujitsu parts, if they're going to fail, I want them to fail here, before I ship it back. But yeah, so tomorrow is basically 8 hours of runtime between the two boards. But let's go ahead, I'll put this up on the camera, or the camera up on the tripod, and I'll just go through and do some shorting out of the controls. I don't have controls hooked up to this to actually play with a joystick, but that's okay. We'll just verify all the controls and the sounds work, and I already know the sounds work. I verified that. So we'll go ahead and do that. All right, got it up, got it right here on the screen. It's got a little bit of a curl in the monitor. It needs to be adjusted a little bit. The furnace is on, so it's going to be a little loud. It is what it is, but we'll go through these sounds. Point it up. Goes right. That is up, I think. Punch. Left. Down. And that's all the controls. All the inputs work. Sounds good. No problem. So with this one we had 1, 2, 3, 4, 5, 6, 7, 7 bad ICs on this board. I socketed the custom CPU. I still don't understand really what this does, what the purpose. If anyone knows what the purpose of this CPU is, please leave it in the comments. Yeah. That's going to do it. The other one was... What was the other one? I've been playing that thing like crazy. I've actually been playing all my games today. Pretty cool. This one was a sound amp. I think that might have been the only thing wrong with this one, was the sound amp. Yeah, I don't quite remember. I think that's it. This one was just a sound issue. Yeah, this one was the basket case, but we got it fixed. No problem. All right, guys. That's elementary. It's all elementary from here. Tomorrow's just going to be a day of running the boards. Maybe, what time is it? Maybe I'll leave this one. It's 8:23. I'll leave this one on tonight so that I can start on something else tomorrow. I'm going to leave this one on for about 4 hours tonight. I'll come back out about midnight, 12:30 or something like that, and check on it and shut it down. But we're going to go ahead and wrap this repair up. I hope you enjoyed, and hope you enjoyed watching the video. A couple Kangaroo boards fixed. And yeah, comment below, what does this CPU do? It's a 4-bit CPU, and it's manipulating the bottom 4 data bits for some reason. I don't know. Is it some kind of a security thing? What's going on here? Anyway, that's it. Thank you very much for watching and supporting the channel, everybody. And we'll see you on the next Classic Arcade Repair. Bye for now.